My name is David Yasinskiy and I will be doing the Calc PC 2009 number 6 FRQ. Okay, the given for you is the Maclaurin series for e to the x is e to the x equals 1 plus x squared over 2 plus x cubed over 6 plus x to the n over n factorial. That's its general term. The continuous function f is defined by f of x equals e to the x minus 1 squared minus 1 over x minus 1 squared, for x is not 1, and f of 1 equals 1. The function has derivatives of all orders at x equals 1. This is the given that you will use for all parts of the question number 6. The first part is asking you to write the first four non-zero terms in the general term of Taylor series for e to the x minus 1 squared about x equals 1. The skills that you need to know is the memorized term of e to the x, the Taylor series. But lucky for you, they gave it to you in the beginning. And manipulating its general term to find the general term of e to the x minus 1 squared. Now, always I write down what is given to me, so I rewrite the Taylor series e to the x, because then what I can do is substitute all the x's with x minus 1's, and then since it's x minus 1 squared, I'm going to multiply each exponent by 2. Its general term of e to the x minus 1 squared is the same as e to the x, except x is now substituted with x minus 1, and its exponent is 2 to the n. 2n, because each exponent is multiplied by 2. 2 points are given for you for this part of the first four terms of e to the x minus 1 squared and its general term. The next part is asking you to use the Taylor series found in part A to write the first four non-zero terms and a general term of the Taylor series for f about x equals 1. The skills you need to know is substitution of your Taylor series that you did in part A, so it's important for you to have it right. Simplifying your f of x, and then writing out the general term of your Taylor series, the new one. Now, always, I write down what has been given to me, so then I can show my work easier. A simple trick is to switch e to the x minus 1 squared minus 1 to negative 1 plus e to the x minus 1 squared, because when I substitute this with its Taylor series, the negative 1 and 1 cancel out, and now I only have it starting with x minus 1 squared, and then I start dividing by x minus 1 squared. I then simplify each part. X minus 1 squared over x minus 1 squared equals 1. X minus 1 to the fourth power divided by x minus 1 squared goes to 2. In algebra, just subtract the exponents. Pretty simple. The general term of f of x is going to be the same as its Taylor series, except the denominator, its factorial, is now n plus 1, because with e to the x, it's 0, 1, 2, 3, 4, but right here, it's 1, 2, 3, 4, because once it starts with 0 and it goes on and on, you have to add 1, so that's why it's 1, 2, 3, 4, so it's n plus 1 factorial. 2 points are given for you for this problem, finding out the first four general terms of f of x and its general term. Next is to use the ratio test to find the interval convergence for the Taylor series found in part B. The skills you need to know is the limit of the ratio test, and an interval of convergence. First, I write down the general term of the limit of the ratio test, if you want to, as a prelude to your work, because it will be easier. Do the steps of n plus 1. Notice that it's the exponent 2n plus 2 is not 2n plus 1. because the coefficient 2 is multiplying n plus 1 in parentheses. That's why it's 2n plus 2. Next, I want to multiply instead of divide because this is a large fraction. So I'm going to multiply and then flip the denominator and then use algebra to factor and break up these terms, so it'll be easier to cancel things out. So x minus 1 to the 2n plus 2 is x minus 1 to the 2n times x minus 1 squared. This is algebra. The factorials, you just have to subtract 1 each time to break it up. N plus 1, subtract 1, you get n factorial. N plus 2, subtract 1, n plus 1, subtract 1, n factorial. And now all you do is just simplify, cancel out terms to get your final term, x minus 1 squared over n plus 2 absolute value. Because the interval convergence, to find it, you do the limit as n approaches infinity and the ratio test. To find if it's converging, you have to make it less than 1. Multiply by n plus 2 and make n goes to infinity. Since n goes to infinity, n plus 2 goes to infinity. So that means the interval convergence is from negative infinity to infinity. 3 points are given to you. You have to set up your ratio. Shows that you know what the ratio test is. You have to show your work that you do to find your answer. 3 points. Lastly, it is asking you to use the Taylor series for f about x equals 1 to determine whether the graph of f has any points of inflection. The skills you need to know are inflection points and taking the second derivative. I want to write down the f of x so that I can then go to the first and second derivative. Anything that is given to you, I write down first so I can start my work. To do the derivative, you do simply a derivative. Bring the exponent down, subtract 1, exponent down, subtract 1. And its general term also. Bring the exponent down, you do subtract 1. Now it's 2n times x minus 1 to the 2n minus 1 over n factorial. That's the same. Now, to what is actually asking you is second derivative. You bring the exponent down, subtract 1, exponent down, subtract 1. Please do not simplify because then it'll be easier for you to find your general term. Now your general term of the second derivative is the same as the first derivative. It's just that now you bring down the exponent, subtract 1. Now it's 2n times 2n minus 1 times x minus 1 to the 2n minus 2. Your general term, it will help because an inflection point means there's a change in sign of the second derivative. But since every term of this series is non-negative, the second derivative will be greater than 0 for all of x. So that means f has no point of inflection because the second derivative is always positive. Now 2 points will be given for you. Finding your second derivative, the Taylor series second derivative, and your answer, which was the inflection points. There are no inflection points. So that's it. The Calc BC 2009 FRQ number 6.